Okay, so here is the other example for section 8.3. We're going to replace example 3 in the note-taking guide. I don't like that one. But I do like this one. So let us graph y equals x minus 1 over x squared minus 2x minus 3. So if we take that rational function, we have a fraction with some variables in it. So again, always look for the horizontal asymptote, any vertical asymptotes, any x-intercepts, and then we'll look and see how many points we need depending on the information we get. So first, the horizontal asymptote, it's always y equals, if there is one. First, we look at the degrees, x to the first and x squared. So that means the degree in the denominator is bigger. So whenever the degree in the denominator is bigger, it's automatically y equals 0. Done. No work to do. For the vertical asymptote, that's when we go ahead and factor as much as possible. So we have an x minus 1 in the numerator completely factored. And then in the denominator, this trinomial, that actually factors. We can do x plus 1 and x minus 3, and that would multiply to give us that. So from there, we know that this would give us x equals negative 1. That makes the denominator 0. And this gives us x equals 3. And that gives us another vertical asymptote. So we have two vertical asymptotes at negative 1 and positive 3. Next, for the x-intercepts, it's what makes the numerator equal 0. So if we have x minus 1 equal to 0, that would give us x equals 1. So that's x equals 1, or as a point, 1, 0 for the x-intercepts. So let's use that information and let's see what the graph would look like so far. So if we start nice y and x axis, there's x, y, get the arrows. Blue lines will denote the markings. So we have y-intercept is 0. That's the axis, but I'm still going through the act of putting it in with some arrows and labeling it y equals 0, just to reinforce that. And then the x-intercepts at negative 1. So here at negative 1, labeling it. And then at x equals 3, 1, 2, 3, we'll go ahead and drop that happy little vertical asymptote there, labeling it for everyone to see. So there's our skeleton of the graph. You can think of the asymptotes as like the bone structure, and then we'll get the meat with the graph in there. So there's the makeup. And then we have 1 point at 1, 0. So we know it's going across the axis right there. So we just have to figure out what's going on over here, what's going on in the middle, and then what's happening over here. So we want to find out what activity is going on near the vertical asymptotes. So it looks like for our chart, this is not easy writing with one hand and holding the paper steady. But anyways, so we have negative 1, negative 2, and 0 are to the left and right of that vertical asymptote. So we'll use negative 2 and 0. And then for this asymptote, we have positive 2, 3, and 4. So positive 2 and 4. So if we find these, put them over there, that should give us enough information. So I say you can use the original equation to substitute in or the factored equation. I'm going to show you how sometimes the factored equation might be easier to substitute into. So if we're substituting in -2, the factored equation was x minus 1 in the numerator. So -2 minus 1 over, and we had x plus 1. So -2 plus 1 times the quantity x minus 3. So -2 minus 3. So we just have some addition and subtraction to take care of. So that's a -3 in the numerator. That's a -1 there times a -5 there. Darken that in. So negative times negative is positive. That makes it a -3 over a positive 5. So then there we go. -3/5. And so I'm going to go ahead and just graph that now. -2, -3/5. -3/5 is a little bit more than half, so we'll just approximate it about right there. And so that already tells us that shape, where it's going to go. I'll fill that in later. But now if we do 0, so if it's x minus 1, it's 0 minus 1. Some of this stuff you can do in your head, and then 0 plus 1 and 0 minus 3. So that's a -1 over a 1 times a -3. And you can see right there, that'll give us a positive 1/3, negative divided by negative. So 0 positive 1/3. Coming over to our graph, 0 positive 1/3 is about right there. So we know that it's going to come down from this asymptote and it has to cross here. It can't come up from the bottom or else it's going to cross the x-axis. We don't have a point there. There's no x-intercepts. So it has to come down, hit that point, then that point. Now, is it going to go back up or is it going to go back down? That's what we have to find. So that's why we're substituting in 2 right here. So if we have x minus 1 over x plus 1 times x minus 3. So that gives us 1 divided by 3 times -1. And this time it gives us a -1/3. Always move that negative up to the numerator or just put it out in front. So that's a -1/3. So over here at our positive 2, we're at -1/3. So let's get that in there. So it looks like it's coming down, crossing, and then continuing next to that asymptote. And let's finish out what's happening over here. That's why we're substituting in 4. So 4 is our x, so x minus 1 over x plus 1 times x minus 3. And so there we go with a 3 in the numerator. That is a 5. And 4 minus 3 is a 1. So that gives us a positive 3/5 this time. So we'll put that in our table, positive 3/5. So 4 3/5 coming over here. 1, 2, 3, 4. And positive 3/5, a little bit more than half. And so now our skeleton is starting to fill in. We know that this point is below and to the left. So that means we're coming along through that point and then down along that vertical asymptote. This series of points, this one's above, so it's coming from above, crossing through that point, crossing that point, hitting that one, and as we get close, it can't turn around because there's no x-intercepts here. So it has to keep going down along that vertical asymptote. Let's get into arrows. And then this one is above and to the right, so we're staying to the right, hitting that point, and staying above. Oops, there we go. And there you go. Good luck.